So once you hit right arrow to calc, you select quadratic regression, which is number 5. Then you hit enter and we'll be given your quadratic regression value. So if you were to plug this data in your calculator, you would get this equation right here. For my quarter 3 I did laws of exponents. For laws of exponents, you are combining terms with like bases and exponents for this first one. So you notice that the exponent in both of these is 5. So you simply add the coefficients of 4 and 6 to get 10x plus 5. When multiplying terms with like bases, you just add the exponents. So for x to the 3rd power times x to the 11th power, you get x to the 14th power. For these, just a lot of rules to memorize. For dividing terms with like bases, you subtract the bottom from the top, so we have x to the 15th power divided by x to the 3rd power, so we'd get x to the 12th power. When we have a power to a power, we simply just multiply the exponents. So for this one, we have x to the 4th power with parentheses to the 3rd power, so we would multiply the 4 and 3 to get x to the 12th power. When a term is outside the parentheses, like the 6 right here, we just distribute whatever is outside, so we would distribute the 6 to the 5x and the negative 4 to get 30x minus 24. Anytime when we have a negative exponent, we always take the negative, or the x, whatever the x times whatever exponent is, and put it below 1, so we'd get 1 over x to the 4th power. And finally, anytime you have any term or anything to the 0th power, it's always just going to equal 1. Okay, for my quarter 3 dislike, I did solving radical equations. Just some key things to remember for this one. You need to remember that the radical term must always be over the other term, and you always need to remember to square both sides. For this one, just takes doing a couple problems to kind of get down what it is to do. So we have the radical x is equal to 4. So anytime we are trying to get rid of the radical sign, we just do the radical times the 2nd power, and that always cancels it. So we square this side. What we have to do to one side, we have to do the other. So we do 4 squared, and we get x equals 16. For this one, we have square root of x plus 3 equals 9. So we are trying to isolate to get our x by itself. So we subtract 3, and then we would square the 6, and we would get x equals 36. And for this last one, you notice on the right side how we have a 2 plus 3, so we simply just add those together, get rid of our radical sign, and square the 5 to get x equals 25. And last quarter, quarter 4, I did a long division, something we just recently did. For this one, you need to always remember if the remainder is 0, then that is a possible factor. This one, again, just doing a couple examples to get it down. So we have the problem 9x to the 3rd power plus 15x squared and plus 0x minus 2 divided by 3x minus 1. So we want to find a term when multiplied by 3x equals 9x to the 3rd. And for this one, we would get 3x squared, because when 3x squared times 3x is multiplied, we get 9x to the 3rd. So those cancel, and we have to do the 3x squared multiplied by whatever else is left, which is the negative 1. So we have the negative 3x squared. And for these, for the long division, you always subtract. So we would do 15 minus a negative 3, which becomes positive. So we have 18x squared. Then we just pull down our next number, which is a 0x. So again, we need to find a factor when multiplied times 3x equals 18x squared. So we get 6x. The 18x squareds cancel. We do 6x times negative 1, and we get negative 6. Again, bring down our next number. So I have 6x minus 2. A factor when multiplied by 3x equals 6x, which is 2 in this case. Multiply the 2 and the negative 1 to get 6x minus 2. And these both do cancel to make 0, so this is a possible factor. For my quarter 4 dislike, I did synthetic division, which is apparently a simpler version of long division, but personally I don't like it. So we have the equation 3x to the third plus 4x squared plus 10 divided by x minus 2. So we are always taking this term right here, and it is the inverse. Since we have a negative 2, it's going to be positive 2, and we put that right here. Then we take the coefficients of each number right here and write them above the top. We always have to remember that if we have a third power and it's squared and then a 10, we can't forget about that x, so we write a 0 in its place. So we have our coefficients of 3, 4, 0, and 10. You always bring down this first coefficient right here below the line, which is 3. And you multiply this times the number below the line to get 6. And for synthetic division, you are always adding, so we do your 4 plus 6 equals 10. Again, coming back to multiply it by our 2 to get 20. Adding 0 and 20 to get 20. Multiply the 20 and the 2 to get 40. And we add the 10 and the 40 to get 50, and our last number right here below is always going to be our remainder. So we write it as 50 over x minus 2, and we have the complete equation of 3x squared plus 10x plus 20 with a remainder of 50 over x minus 2. And this is just another one. This one so happens to not have a remainder, just some more practice. And for my real life example, I just did graphing parabolas. Since it's just graphing, the equation will be given to you. So I wrote the equation y equals negative x squared plus 20x plus 50. So I wrote the problem: a ball is thrown off a building at a height of 50 feet. So we got to remember that the ball is going to be starting at 50 feet. The ball ascends 10 feet before reaching its maximum height of 60 feet at a rate of 20 miles per hour. So since we know that the ball starts at 50 feet and it's going at a rate of 20 miles per hour, we also know that the maximum height is 10. So we go down here to our distance, which is 10 feet, and kind of just go up. And we know that it ascends at 20 miles per hour, so if you were to put in your graphing calculator, you could kind of just get an idea of what it would look like.